Alright, the second of 3 videos on the first part, Chapter 2, takes functions a little further. So this is about function notation. So before I get into the basics of that, I'm going to show you something from Algebra 1 that should seem like review. So I give you an equation like this, right? A linear equation, y equals 3x minus 4. Think about an xy table. It's a very basic xy table. I'm only going to give these points. So -2, -1, 0, 1, and 2. So if I plug in -2 into x, so right there, what happens to y? Well, this would be, so let's use blue. -6 minus 4, so that's -10. If I plug in -1, it's -3 minus 4, so that's -7. If I plug in 0, it's 0 minus 4, it's -4. If I plug in 1, it's 3 minus 4, so I get -1 back for y. Right, I'm just plugging in x right there, getting back y. If I plug in 2, then it's 3 times 2, that's 6 minus 4, so that's 2. So basically what this means is, this is a line right here. It's also a function. So right, it's a linear function, as in it makes a line, right? Line or linear, and it's also a function. So these points, so -2, -10, -1, -7, 0, -4, 1, -1, and 2, 2 are all points on this line. So again, piggybacking off of the last video, right, x is my input, and y is my output. Ran out of space there. All these numbers are also my domain, and all these numbers over here are, again, what's called the range, right? The set of all outputs. Just kind of reviewing there quickly. So this linear function here, you should hopefully understand how I got the table I got. So let's look at that in a slightly different way. So instead of saying y equals 3x minus 4, I'm going to instead erase y and put this symbol there. So what this is, instead of being y, I've put what's going to read as f of x. So f of x. Basically, it's the function f. Okay, f for function. If you haven't seen this before, what this basically means is I have this function. This function is called f. I plug in x. So x is my input. And then this whole entire thing is my output. So I'll just put O for output. If you want to write output in your notes, you probably should. So it's the exact same thing as before. I just wrote it in a different way. Because usually, f of x is the same thing as y. It's just written differently. It's basically written more like a rule, where I plug in x, and I plug in x here, therefore I plug in x here. So, again, this reads f of x. You'll be reading that out loud in class, so I make sure you have it right. So, for example, if I had f of 4, that means the input is 4. So it's 3 times 4 minus 4. I just took this right here, replaced the x with 4. So that's 12 minus 4, that's 8. So f of -4 equals 8. In the same way, f of 0 would be 3 times 0 minus 4. So that would be -4. So whatever I put into the x, right, that's my input, I do the same to every x I see, which is what happened here and here. So now I've got a different function. This is function g. So I'm going to read this as g of x. So it's the function g where this x right here, that's the input. So this x is the input. So I basically plug in x, and what happens is I multiply it by -5, then, key word here, then I add 10. Because again, order of operations, multiply, then add. So let's look at a few examples. So if I, for example, wanted, and I'll change colors, f of -2, well, that would just get me 20. Because I have -5 times -2 plus 10. If I showed the work, it'd be like this. -5 times -2, which is positive 10, plus 10, I get 20 right there. If I wanted, for example, f of, let's say, -1, well, that would be 15, because it's going to be -5 times -1 plus 10. Notice that when I'm plugging in to this x, right here and right here, so instead of -5 times x, I have -5 times -2. I'm using parentheses because you want to do that to keep the order of operations from making a mistake, and I'll show that next. So I have here 5 plus 10, that's 15. One more I'll show. If I had, let's say, f of 2, well, that would be -5 times 2 plus 10, which would actually be -10 plus 10, and would just be 0. So in other words, from this function, 2, 0 is a point, because x, y. Because again, f of x, when you see that, in this case, it's actually g of x. So in your notes, I apologize, but these should all be g of x. Sorry to confuse you there. So g, and then this one would also be g. So g of x, f of x, h of x, doesn't matter what letter you pick, just however you want to name the function. That's the same thing as y. So that's a point. The point -1, 15 would also be graphed here. If I graphed it, I'm not graphing it here, but if I did, the point -2, 20 would also be graphed here. So these 1, 2, 3 are all points in this function. So I'm going to show one more bit of a challenge one, and then we'll be done. So let's say I have this function. So f of x, again, f of x is -2 times x squared, and then plus 3x. So I want these 4 points. I want f of 0, I want f of -3, I want you to find f of 5, and I want you to find f of 1. So challenge yourself. Right now, pause this and try and figure out what all of these would be. Tell you what, you get it right, don't take notes on it. It means you get it. If you get it wrong, write this down so you can see it for the future. So right now, go ahead and pause this and try and find all 4 of these. Pause it now. Here's the first 2. If I plug in 0 for x, well, guess what? I also get 0 back for y. Because 0 squared is 0, and then 3 times 0 is 0, easy enough. If I plug in -3, I get -2 times -3 squared. -3 squared is positive 9. -3 times -3. So that's -18. And then plus -9 gets me -27. So if you haven't yet, keep going. Pause it and find the next 2. So you plug in 5 for x, you should get -35 for y. And you plug in 1 for x, you also get back 1 for y. So you plug in 1 for x, you get 1 back for y. So that's it here for functions. Just kind of showing the basics here. Whatever you have for the input, so you plug in 0, for example, replace every x with 0, evaluate it. You plug in whatever you plug in for x, for example 5, plug that 5 into every single x you see. Okay, that's it for now. See you later.